Okay, let's look at problem number 9 from the free response. So let's see what we have here. So again, this is the first time we're looking at this one. We're going to delve into it a little bit more deeply. So just kind of follow along with this one. I'll go through and explain it. So we got a coffee pot that has the shape of a cylinder, and its radius is 5 inches. And the depth of the coffee pot is measured in inches, is a function of time. That makes sense, right? The depth would depend on time, measured in seconds. And the volume is changing at a rate of this. That's the rate of change of the volume. And then they just tell us what the formula for a cylinder is. So the first thing we're supposed to do is we're supposed to show that dH dt equals that. Okay, so in order to do that, we need to know a couple things. One, basically what's going to happen, think about it as this, is what we're going to be doing is we're going to be taking this function right here, V, the volume equals pi r squared h, and we are going to solve it, we're going to take the derivative of it and solve it for dH dt. Okay, that's the idea here. Let's see the different things we know. Some of the things we know, one of the things we know is dV dt, right? They told us that equals negative 5 pi. I'm going to write it as h to the 1/2. Okay, I don't know if, actually, it doesn't matter. I'll just leave it as h to the 1/2, just in case I have to do stuff with it. Okay? Also, take note, because this is kind of, I forgot something there, didn't I? This is volume, I wrote pi twice. So it's pi r squared h. So take note, the radius is a constant, right? This is a cylinder, so I'm going to do a really poor job of drawing a cylinder, right? This is a cylinder. This radius is not a variable. It's constant. It's 5 inches, whether the cup, has almost nothing in it, or whether it's empty or whether it's full or somewhere in the middle, the radius is always 5. So it's not a variable. It's not something that's changing. So in other words, I can rewrite this formula is pi 5 squared h. Okay? I can plug in the radius right off the bat because, again, it's a constant and I want to treat it like a constant. So let's actually just clean that up a little bit. Okay. Let's see what we can do. So we're going to go take the derivative of this with respect to time. So we're doing this implicitly. So this is going to be dV dt equals 25 pi. The derivative of h with respect to time is just dH dt, whatever that is, right? In fact, that's what we're going to be solving for. Okay, let's plug in some numbers. So dV dt is negative 5 pi h to the 1/2, and that equals 25 pi dH dt. Dividing both sides by 25 pi, I get negative 5 pi h to the 1/2 divided by 25 pi equals dH dt. Simplifying that, we get, I'm going to do this off to the right, looks like we get negative h to the 1/2, pi's cancel out, 5 on the bottom equals dH dt. So we get exactly what we showed, that's what we get. Okay? Not a lot to say there. So the only things I would point out to you on that is when we're doing a rate of change, right? When we're doing these rate of change problems, if you have to be careful, right? So for example, had this been a cone, right? Had this been, I don't know why this coffee cup would be a cone, but if this coffee cup had been a cone, then the radius would have been a variable, right? Because as the coffee goes down, the radius would have gotten smaller and smaller and smaller. So we would have had to treat the radius as a variable, and we would have had to keep this with respect to r as we were taking the derivative, right? Because the radius would be changing with respect to r, with respect to t, time, okay? In this case, though, right, our coffee cup with a cylinder. So as time went by, it had no effect on the radius. So when we took the derivative, you wouldn't say, hey, this, the radius is changing. Why would you take the derivative with respect to time in that case? Because the radius is constant. So just be aware of that. Let's move on. Okay, given the height is 17 at time 0, solve the differential equation. So this is very similar to some of the last problems we've seen. They're just asking us to solve this, plug in a particular number, and move on from there. So let's see what we got. So again, there's nothing to see here. You have, at this point, this should be the third time you've actually done this. Okay, so I'm going to rewrite this as negative h to the 1/2. Actually, you know what? I'm going to completely rewrite this. I'd rather write this as negative 1/5 h to the 1/2. Let me just double check to make sure I wrote that correctly. Okay, that looks good. Okay, so again, all we're going to do is we are going to integrate this, plug in the appropriate point, and then solve for h. Okay, just like we did in on problems, I want to say 7 and 8. So let's go and do that. So we're going to use separation of variables here again. So I'm going to say dh. I'm going to divide both, get the h's on one side and get the t's on the other. Let's make sure that does look good. So this is going to become h to the negative 1/2. dh equals negative 1/5 dt. So let's go and integrate our stuff. So we're going to get 2h to the 1/2 on the left and negative 1, that's not a 1, negative 1/5 t plus some c on the right. Now, I do want to remind you, I talked about this last time and I'll talk about it again. That plus c is so important, okay? It's so important. If you don't get that plus c, you're going to probably miss most of the points on the question, okay? Because they're asking you to find a specific equation. If you don't have that plus c, you won't be able to find a specific equation. So super, super important. Okay, let's keep on going here. I think at this point, I am just going to substitute in my value. So let's go and do that. So let's plug in our point 0.17. So this is 17 to the 1/2 equals negative 1/5 0 plus c. So this is going to be, I'm going to actually rewrite this as a square root for no good reason. So c equals 2 times the square root of 17. So from here, let's go take this value right here and sub it in for c. So we get 2h to the 1/2. Again, I'll just write that as a square root of h. It doesn't matter at this point. We are done with the calculus on it. And plus c, which we said is plus 2 root 17. Okay, now remember, we got to solve this for h. So I'm going to divide both sides by 2. So I get the square root of h equals negative 1/10 t plus root 17. Squaring both sides, we get this. Okay, that's it. That's it, that's it, that's it. Let's move on to letter C. What is that C? At what time is the coffee pot empty? Now, this one's kind of weird one in that I don't even understand why they're necessarily asking it. And the reason I say that is, well, okay, I guess the reason they're asking it is they want to determine if you know what equation to use. I'm assuming that's the reason the question was asked, because otherwise it's not much of a question. And the reason I say that is, well, this thing is empty, I think you guys would agree, when the height is 0. So we want the height function, the position function for the height. Well, we just found that. This is our height function. So all I'm going to do is I'm going to copy this because I'm lazy. Let's bring that down here. So here it is. I'm just going to copy this, set h equal to 0, and solve. There is, like I said, it's not, I don't know. I mean, I guess it's more of a concept question. Do you understand, right? Do you understand which function you're going to use? But it's, I don't know. It wasn't, in my mind, it wasn't particularly crazy. So I want to know when this is true. And this is true when negative 1/10 t, positive 1/10 t equals root 17. Multiply both sides by 10. So when t equals 10 root 17 seconds, right? That's when the coffee cup or coffee pot is empty. Okay, that is problem number 9. I will see you in the next one.